Hi, this is my first tutorial on how to use Go language for wireless communications. So today we'll start at the first example, how do we generate a sine waveform, add a Gaussian noise and see a noisy sine wave on a plot. We'll assume that you have already set up the Go language tool on your Linux machine, and you can also install Go on your Windows machine. That's a separate tutorial. So today I'll be using Go language on a Linux platform, and I'm using a Sublime text editor. And we'll also use plotting tools. We won't be using MATLAB, but we may use an alternate tool to see the data that we're generating from the program. So here we go. So what you see is we'll start with generating a sine waveform and generate a Gaussian noise and add a noise to the sine wave and then see the output of the noisy channel. Let's start doing it. So now what we see is that let's start a simple example. This is package main. Try a simple example. It says main fmt.printf hello world. Note that it automatically imports this package fmt here because I'm using the Go import tool, which you can Google it out. So basically, it automatically imports whatever package you are referring to. And as soon as you stop referring to the package, it can immediately remove the package also. Now, since it has already imported this package, let's go here and say go build example1.go. Right. So look at the code. So generate this file called example. Direct. So it says hello world here. Okay. Okay. Now let's start generating a waveform or use basic math package, and say that you are looking at a math package. Uh, with the Go Sublime, it has a very quick shortcut handy tool for add and remove package. So go here, add remove package, and say you are looking at a math package. So it says there's a standard library math, input it, and you got the math package imported. Math dot, right here it is. You have a math dot sine function which generates a sine value for the given argument x. Okay, and note that all the functions which are exported always starts with the capital letters, which I assume is known. Maybe we can cover it on another basic tutorial on typical syntax of a Go language. So we got the sine function here. Let's say we are looking at values from 0 to pi, and we'll check the output of the value, and then we'll see, we can try to plot the values, right? So here is my argument alpha. Let's say x, which is very common to say. And note that we are not already defined a variable called y, right? So I'm using this operator, which actually creates a variable on the left. And if you just put your pointer on the sine, it says that is a function sine takes an argument which is of type float 64, returns a float 64 variable. Y is a float 64 variable which is generated. Okay, and let's generate a for loop. It generates values from 0 to, say we want to start from 0.0 to a value. These values are x which is 2 into pi, but that pi is a constant available in the math package, right? Okay, and let's go all the way till less than or equal to pi, 2 pi, and x plus equal to, let's do 0. And every time the value y is generated, try to store this in a variable y, the float 64 value. Let's start bring it back on the screen. In def, let's say we want to give a new line character. Let's say let's give a serial number to that, maybe a counter, where count thing, let's say cmp plus plus counter. Want to see this percentage d, and then percentage f for a float, which is x, and then we have percentage y, other f, which gives y. So count comma x comma y should give me for each of the samples. We see what is the x, the pi value, and what is the corresponding sorry, the theta value, and what is the corresponding y we are getting. Okay, let's start running this code. Okay, so go run. See, basically Go allows you not only directly to run the code and build the code, you can actually start running the code. So when you say go run example.go, it it does the build as well as starts running the code. So, and it does not generate the intermediate executable file. So in this case, go run example1.go, it just starts running. Okay, okay, we have this hello world. We should say not. Good. Okay. Okay. What I should notice control command control B. So you got it, right? So you have running from 0 to 31 samples, 0 to pi, right? 0 to 2 pi, and here are the y values. Let's say that we are interested in plotting this value, okay? And if you notice, it does not, it's still at minus 0.08, and we should be seeing 1 somewhere. Right? Sine 0, sine by the 2 should go to 1. Okay. Let's try to plot these values, okay? Yeah, say that you're this is still going into the shell, right? Why not we redirect this output to a csv file, and then we'll see how do we plot this. Okay, or start assume that you want to redirect it to a file. We could say we are looking at a file package, add package io right? Let's say io dot OS package. We got this OS. Okay. OS.create creates a file. Let's say output.csv, and let's assign to the, and please you should note that the output of this function are actually two arguments. There are two output. One is the pointer to the os.file structure, and then there is an error. Basically the error would say whether you the if the system was able to create a file or not. Okay, let's catch both that. Basically not catch, let's say fd is the file pointer comma error, and on the fly we create both the variables. If there is an error, we would like to see. If error is not equal to null, we would like to know what happened. We'll say p.printf, sorry, there is a file open error. And what was the error? Just print the error, right? Note that the println function takes care of all the data types, and it knows how to print those custom data types also. And once we print this, we just return out of this. Okay, we are not interested in anything. Fine. Okay, FD is declared and not used. Okay. If it is not error, if there is no error, what we do is we want to write into this file. Going to this, instead of the screen, we could also dump it into fmt dot fprintf. Basically, fprintf takes the first argument, which says where do you want to redirect the output. So by default, the printf will redirect to the screen, where standard std out, whereas we would like to redirect to this file pointer, which is fd, and rest remains the same. So we just copy rest of them. Okay. So we may, okay, let's have both the screen as well as this. Let's do this, colon, and here we got. Let's open the file called file output.csv. Okay, so got it, right? Okay. Now, what we would like to do is let's add the first name, the first row with the column names, which will be useful later on. Say fmp dot fprintln. We don't want to format because we know what we're writing. Fp, I'd like to say is this is the first one is the index, comma, and maybe we should do also here. So, ultimately, we are looking at a CSV kind of file, and then we start using in our plotting tool. Index, you have then you have buyout. Now let's again. So note that we only gave it in the CSV file. Open the CSV file. Here we got. So if we have an extra slash n coming in, maybe we should. Okay, it was not an ln. We don't want a new line there. Start with a new line. It should end with a new line. Same here. I think we should just ignore this part. And note that do not close the file, even though the system will close it. Okay. Go run example1.go. Yes. Okay. So you got the file. Uh, yeah, it's fine. So now let's start plotting this data. Okay. So to plot the data, what I've done is, just note I'll be sharing the link. You'll be able to see the link where I have hosted a small index file, which basically is a C3JS based tool which takes a CSV file and plots, gives a line plot. And you also need a small tiny HTTP server where it'll be rendering the HTML file. Note that you could use a Chrome browser to render the CSV file, the HTML file, but we are referring to the CSV file, which is a local file, right? So it's better if you can have a small HTTP server. And if you're looking at a HTTP server, there is a small code. I mean, Go can actually run a small tiny HTTP server. It has a built-in package. I've also shared a small code which just runs HTTP server in the current folder, and we'll be able to use the browser to uh, uh, render the HTML files in that. Okay. Would like to see is the file that I have shared is this. Basically, it's a simple HTML file which has just some header which says tutorial, a plot of the CSV file, and then there is a small debug event. Which is, I mean, those are not related to HTML or web technologies. You may just ignore this because you just have a CSV file. You may use a MATLAB to load the file, CSV file, and then you can plot it in MATLAB also. I have a MATLAB ready. Maybe I can do it there, or we'll do it in the browser. Okay, just give me a second. I can. So what I do is start an HTTP server. Okay. So what we're seeing here is that tiny HTTP server running. It has just loaded the file from output.csv. You can see that it basically the HTML file takes care of it. The C3JS takes care of the values. Uh, if see it sees that there are three columns, it takes each of the column and plots a graph, right? So, for example, it has also plotted the first column is index. I think that's not needed. Maybe what we'll do is we'll just remove the first column from the code and just plot only the. I'll show the Go code later. Let's do this. Yeah. Okay. Here we go. Okay. So you have so basically it shows what the theta value is. We know that theta is increasing from 0 to 6 point. Where should theta go all the way here? Yeah, so here theta goes up to 6.2, which is here, right? 0 to 2 pi. Whereas this is y out is the sine value which goes all the way from 0 to from -1 to 1, right? So let's run this again and let's plot it with respect to x versus y. Basically, let's take theta on the x-axis, y on the y out on the y-axis. There's a small change in the index file. What we see is x-axis is theta uh, and y-axis is here we go. Right. So now you can see that this is y out all the way going from here and here. Right. So one more step, it should have come to 0 again. See, so what I changed is the first column, and we just plotted only two columns. So here you see this theta and y out here, and the we have theta first column, second column is y out, and I just changed the corresponding Go code for that. And we have index.html. There's no change in the index.html as such. Oh yeah, so that is here we go. Yeah. So here what we mentioned is that we say that the x-axis takes the column from theta and y-axis takes the column title y out, right? And then this does the plotting. Okay. Going back to this code. So what we see yeah. So let's say that we run this from instead of 2 pi, let's run this till 10 pi. And code done. See the CSV file all the way till 31.40. That is now. If we go back, switch back to the browser, you see the output plot. Refresh this. Here we go. Right. So you got the sine wave generated. So you're done with the first thing. Now let's start adding some Gaussian noise to this. Okay. To add a Gaussian noise, let's look at the package that we get. Golang. Put up goes to this. Okay. So Godoc is a server which actually scans through all the packages available on GitHub. You could actually give the GitHub path. You can find the documentation of the particular package. Right. So let's go to the look at the package here. So we are looking for math. Right? So we have this math, which is a standard library. If you look at this, which is a GitHub hosted third-party package, is github.com/math. Let's look at this math rand. Okay. So what we're looking is a normal distribution random variable. Let's look at this example. So just like those are familiar with MATLAB, you know that you could set the seed and then so that every time you run the simulation, you always get the random sequence coming, random values coming from with the same seed, right? So especially if you're repeating an experiment, you would like to know, are you seeing the same sequence of numbers? And this will be useful in other simulations we can talk about in later sessions. Let's take an example. How do you generate a random variable? Okay. Let's see this. So it has, the package has few random variables, generating integer random variables. There's a 32-bit integer random variables. You can generate a 64-bit integer random variables. Then you have a float random variable. Yeah. Let's take it. What does a float random variable does? Float 32 returns a float 32 pseudo random between 0 to 1, right? Whereas integer generates a number between 0 to uh, the maximum size of the uh, integer range. Okay? So if you look at this, integer 31 basically returns a non-negative pseudo-random variable of 31-bit integer. And if you're looking at an integer variable between 0 to 10 or something, what you're looking at is basically this. This is a function that you should be looking at. Int n says that returns an integer variable within the region 0 to n. Within the value 0 to n. Note that it excludes n from this. Okay. Now let's generate a norm random. So what we're looking at is actually a normally distributed random variable, float 64. Note that Golang is strictly typed data. It has a strict data type. If you look at this function, we know that sine function basically generated. It takes an argument which is 64-bit. It generates an output which is 64-bit. So if you're adding to the sine wave and the noise should also be of the same 64-bit float variable. Okay, so we'll be using a norm float 64 here. Okay. And okay, so the tutorial, the documentation also says how do you generate a different distribution, basically the Gaussian noise with different variance as well as mean. So this turns out handy. Let's look at. Let's go to the code back. So I'm sharing the screen back. Go back to the screen. Okay. Let's include the RAM package. Add package. RAM. Okay. So yeah, note that there are two packages. There's a crypto rand and a math rand. So we look at the math rand package. We got the math rand here. Change the noise variable called noise equal to rand dot. I'm not sure if we're able to see the auto-completed pop-up menu which generates norm float 64 is added to this. And if you remember, the sine function is generating a value between -1 to +1. So adding a Gaussian distribution which is between with the variance 1, standard deviation 1, I mean variance 1 is actually maybe too noisy, right? Let's say we increase the peak values of the sign. Let's say 10 into this. So we are expecting values from -10 to +10, and then we'll add noise to that. So now we have noise which is between with the variance 1. So we are expecting that Gaussian distribution will take values from -3 sigma to +3 sigma most of the time. So we are expecting we may have a sine wave with noise all the way till 10 plus minus 3, right? And there will be some more spikes also. Let's add that. So let's generate one more noisy waveform, right? So let's say z is a variable which takes y plus the noise, y plus noise. And so what we're expecting is that we'll be having one more column, which will be the noisy samples, right? So let's give that name as noisy. And we also need to change the index. And it should be okay to take two of them. Okay, so for an example, so note that there is an extra argument given to the printf function, whereas uh, the format has only percentage %f and percentage %f. So it's expecting only two input arguments. Let's give one more percentage %f to this. Then we'll read in the code. So here, and we got theta, we got y out, and the noisy samples. Now if you go back to the plot, yes. Okay, so okay, I think I have to switch the screen so that you could both share. Okay, here we go. Right. So you see y out and the noisy samples. So say if you click on this, you just see the noisy samples, and then you can see this. Uh, so all the way till here. I mean, look at this values. The peak is this. The noisy goes always almost like 8.6, 10.2. Okay. So what we've done today till now is like generate a sine wave, add noise to that, a Gaussian distribution noise, and we saw how to plot the values. Okay. And this is the end of the tutorial for today. Hope you liked it, and we'll go more in details. We'll start using a vector and then see how do we generate the samples in vectors and add two vectors. And thanks for watching.